5 and 6 today, no calculation. Concept. That means boring. Okay, design and goods and service. Design. Okay, design. Why design is in operations management? Why? Why design is important in operations management? Any opinion? No. Let's see. Operations management. Do you remember? Make it better, cheaper, faster. Okay. For example, this one, chair, right? When I worked at one of Minnesota State University, at the time, student chair has something basket here. Basket. The role of a basket may be placed in the bag and placed here, right? But nobody used. So that is unnecessary, right? Okay, to make a basket under the chair, need more parts, right? That means more cost. And then to assemble the chair, need more time, right? And then it's like the chance of defect. Chance of defect. More parts, more chance. Less part, less chance of making defect, right? So reduce the number of parts, less chance of defect, right? That means get rid of the parts, improve quality, right? So design better, get rid of unnecessary thing or parts, make it faster, make it cheaper, make it better. So better design is in operations management. Good? Okay. Product design process, typical phase is product design. Concept development. Decide what we will make, right? And then how to make, planning, right? How to and when. And then yeah, when. And then product process engineering, how. And then pilot, something, make it something and then test, right? Okay, that is, these are typical phases. Okay, so concept development, product planning, engineering, and pilot production, and so on like this. And then each one has some activities like, looks like project, right? Chapter 3, right? Project. So concept and so on like this. Okay. Concurrent engineering. This is the simultaneous development of project design functions. Simultaneous development. Many activities. First one, finish, and then next one, finish, next one start like this. one after another. We can say this one is sequential development. But simultaneous development, if we can do something overlap like this simultaneously, then sequentially take this long, but simultaneously this short. So when we design something, if we can do multiple tasks, works together or simultaneously, then we can make it faster. That is concurrent engineering. Then parallel completion. So simultaneous concurrent engineering need simultaneous and parallel completion, not sequential. Sequential means one after and another. And cross-functional integration. Cross-functional integration means, have you heard the TF, task force? To do something, choose people and make team, right? For a certain purpose, right? Special team, right? The same. To do multiple works jobs. Okay. Concept development, product architecture, design, target market. What kind of people we need? Designer, marketing people person. How about investment, money, so financial department,
Quality.
and so on, right? So to do these multiple works, many people we need, right? So make a team from a certain department and then make a team. That is task force, right? Task force team, TFT. Or we call that team as cross-functional team. Cross-functional team, cross-departmental team. Cross-functional team, cross-departmental team, or interdepartmental team. Interdepartmental team. Interfunctional team. Many different names, but the same. Gather people from different functions, then make a team. That is cross-functional integration. When I cover this part, I ask the student, can you do like this 1, 2, 3, 1, 2, 3, then 1, 2, 1, 2, 1, 2 like this. 10 times 1, 2, 3, 1, 2, 3, 10 times 1, 2, 1, 2, 1, 2 like this. If I have only one hand, I should do this one 10 times, finish, and then 10 times like this, right? If I have only one hand. And then if I can use two hands simultaneously like this. Which one is faster? One hand or two hands? Two hands, right? That is cross-functional integration. Multiple job, multiple people work together. Okay. And then open interactive communication among all team members. Physically together or in cyber area using online. Anyway, communication is important. What you do when you finish, something like that, right? So benefit, guess. If we can use concurrent engineering, what can be benefit? Faster, better, cheaper. So benefit, textbook says blah blah blah. Reducing time, faster, right? And decreasing cost, cheaper, and improving quality and reliability, better. So design is in operations management. One of the concept in design is concurrent engineering. Okay, next one is, do you need more time? Anyway, this PowerPoint is on Blackboard, so you miss some parts, then you can find this file on Blackboard. Quality function deployment, QFD. An approach to get the voice of the customer into the design specification of a product. Okay. If we can make something customer like, can sell more, right? Okay, how can we make something customer like? Here, right? How can we hear? Using survey, in interview, ask what you want, what you need, and then make something. Then we can sell better, make better, cheaper, faster, and sell more, right? That is QFD, nothing special, but people get it. How can we hear, right? That is QFD. Benefit. Guess what? Fast. Better, cheaper, faster, right? Our textbook just say shorten product design time, faster, reduce cost, cheaper. But if we know what they want, we can make it better, right? So add better. Also quality used by QFD, based on QFD. Using a QFD, we ask and then we know what they want, right? Now, we should know ourselves. We can make. Using this house of quality, looks like house. Call this house of quality. By QFD, we know people like easy to close. It's a car door, and stay open on hill, open and then stay, and then easy to open, and so on. Okay, we know what they want, and then technical characteristics to make those things, what technical things we need. And then this X, where we are. And then A, B, others, competitors, where they are. Then compare. Our technical ability is low. Then we know, right? We should invest something there. Then make it improve, right? So using QFD, find where we should improve or where we invest something like that. Okay, this is household quality. So, a matrix of customer requirement information based on customer feedback from QFD. That is household quality. Value analysis, value engineering, VAVE. This is cost avoidance method by simplify product and process. How can we simplify? Earlier I exampled the chair. Reduce the number of parts, right? How? Eliminate unnecessary features. Earlier, a commercial Kia Sorento. I don't know you watched that one or not. One time Kia Sorento advertised the folding side mirror. Have you watched that one? The side mirror inside push button and then fold up. That function is kind of required in Korea because the parking space is very narrow. So if we park, then the space between cars about this much. So open door and then out and then like come out like that. So side mirror, people hit the side mirror. So folding in Korea. But here, have you seen a car folding the side mirror? I saw a couple of times because many Korean live here. So they use it's like a habit. But here we don't need, right? But Kia advertised that. In the United States car market, that function is not necessary part, right? Just get rid of that function. Instead, give something other, right? Or just to get rid of, then save cost, right? And then sometimes that one malfunction. So defect, right? Have you heard JD Power IQS? I told you earlier, right? Initial quality study, first 90 days, 3 months is what? Defect, right? The number of defect out of 100 cars. Maybe that function is one of the factor, right? So, eliminate unnecessary design feature. Combine two or more parts. Two parts make one part and then assemble. Cheaper, faster, better, right? And then cut down the weight. If something is very heavy, then it's hard to move, right? Make it lighter, then move fast, right? And then eliminate non-standard parts. Okay, all parts are standard, then we need only one tool, right? One size of tool. But standard, non-standard, standard, non-standard, then we change tool, right? If we use all standard part, then easy, that means faster, cheaper, better, right? So that is value analysis and value engineering. Guidelines like this. Many different parts, more number of parts. Make it simple by minimize number of parts. Eliminate adjustment, make it 2 or 3 part 1, and then screw and other fasten the same story, standard parts and so on. That is BABE. Wow. Benefit. Make it better, cheaper, faster. Better. From reduced chance of defect. The number of parts, reduce the number of parts, then the chance of defect drop, right? That means make it better, high quality. That's all for chapter 5. Fast, right? Only fast or better? Okay. Chapter 6, about quality. This part also boring part, blah blah blah. So please be patient. Okay, when we say quality, someone maybe different concept of definition of the quality. So you say there is no one definition of quality, many different, based on view. Transcendent view, product-based view, user-based view, manufacturing-based value-based view. Depends on view, different definition of quality. First one, transcendent view. Quality cannot be defined precisely. And it is unanalyzable property because we don't have numeric data. And recognized only through experience. Even direct experience or indirect, someone's. Mercedes-Benz. Have you had Mercedes-Benz? No? I didn't have, but I drove. But anyway, people think Mercedes-Benz is nice car, right? How? How do you know? Just people say, and then it's expensive, right? And then look nice and so on like that. Even we don't have experience, but from others' experience or just hear and then look. But we don't have any numeric data, right? But we know, right? We we know that is nice. Quality is innate excellence from reputation. Something like Cadillac, Mercedes-Benz. We just know, right? We didn't test, but we know, right? From a reputation, somebody's experience, and so on. That is transcendent view quality. Next one. How about Hyundai? What do you think? Or Hyundai Sonata? Even you don't have experience.
Great warranty.
Great warranty only. When I was in Korea, I drove a Hyundai Sonata. But at the time, the car was not good. Many parts. So, I heard now it's a nice car, nice warranty too. But still, I don't have good reputation with Hyundai because my experience earlier was not good. So anyway, that is a transcendent view to me and the Sonata. Product-based view. Quality is a precise and measurable value because we know quantity of some ingredient or attribute. Maybe someone, but not many. When you buy something like a can of soup, then the size, right? Like 16 ounce. Maybe nobody test, right? But we can test, right? Because it's amount compare, right? Or like me, you know, I like to play golf, right? So sometimes I need a tea, right? So go to Walmart and then grab one bag of tea and then it says 100. I never, but maybe count. If it's only 95, what do you say? No, not good, right? But count is 102. Wow, I'm lucky. But anyway, we can measure, right? Because there is amount, right? Quantity and something. So, product-based view, there is number, so we can measure. That is product, there is view quantity, quality. User-based view. It says idiosyncratic and personal. You know, store name is Dollar Tree. You know Dollar Tree? Something else here, right? What is the name of the kind of store? Anyway, Dollar Tree. Supposed to be $1 everything, right? But actually not. Backside there's something higher than $1. Anyway, $1 tree. What do you think? Is it okay? If you want something, then go to $1 tree and then buy something. Okay. Okay. I like cheap and then affordable. But someone says, okay, to me it's okay, but to somebody not okay. But the same one, person to person, different quality, right? User based. Idiosyncratic and personal means different, person to person. Even the same one, person to person, different quality. That is user-based view quality. manufacturing based view. If I design something 1 inch, then produce, and then inspect every out, measure. Then first one, 1.02. Second one, 1.05. Third one, 0.99. This one, 0.98. This one, 1.01. Okay. One more thing. One more. 1.00. Can you say which one is good, which one is not good? This one is good. Because I designed 1 inch, exactly 1 inch. How about others? Can you say not good? Yes or no? Not good? Before specification, we cannot say. Manufacturing view quality is conformance to the requirements such as the design and specification. Design and specification 1 inch, but deviation from the desired quality level. Conformance quality. This is conformance quality. If I give something specification 1 inch plus minus 0.02. Then from 0.98 to 1.02. Inside this range specification, we can say good. Good, not good, 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 absolutely good, right? So before that kind of specification, we cannot say. Okay. So that is manufacturing-based view quality. So we can conform in certain range, then acceptable, and then that is good quality. Refers to the degree to which the product or service design specification are met. Okay, design specification 1 plus minus 0.02. Meet that specification, then we can say that is good quality. That is manufacturing-based view quality. Value-based view. Do you remember value? Something over something. Chapter 1. Something over something.
Quality over price.
Good, thank you. Exactly same, identical products, but different price. $100, let's say $80. If you need one of them, which one you will buy? Absolutely this one, right? Why? Cheaper, but another name higher value. That means the same as high quality. So cheaper buy cheaper one that is high value, but people think the value is quality. So higher value, higher quality. That is value-based view quality. Designs, dimensions and dimensions, design quality. When we design dimensions, performance, primary product or service characteristics. Okay, passenger cars, what can be a primary characteristic? Okay, television. What can be a primary product characteristic?
Size.
Nah. Picture quality, right? The main thing. Size, maybe.
Because if you have a 30-inch TV, you're sitting across the room, a 6-inch TV is the most important part there.
And how about a feature of a television? Something internet available, and reliability, consistency of performance over time. Turn on, turn on, turn up, turn up. Increase the volume, increase, decrease. Every time what I want, it work, right? But Philips, turn on, about 10 minutes later, turn off. Turn on, 10 minutes later, turn off. Sometimes not work. Durability, maybe same, right? Last long. And serviceability, easier there. Philips, that time, my experience, 6 months is. Response. Even 1 week, 2 weeks, 3 weeks later, no response. And then aesthetics. Something sounds good, feel good. At that time, the Philips was sound good, feel good, look good. And reputation. Before my experience, the Philips reputation was there, but after my experience, reputation down. So when we design something, we should cost of quality. Okay, to improve quality or maintain quality, we need cost. Appraisal cost, prevention cost, internal, external failure cost. First one, appraisal cost. Costs of test to ensure that the product or process is acceptable. How can we know? Test, right? Test, inspection. So cost for inspection and testing. Okay. By test and inspection, if we find something cause of defect and then cause of defect, what we should do? The sum of all the cost to prevent defect. So, cost of identifying the cause of the defect and action to eliminate the cause. We design the product or process. Cost, right? Time and cost we need, maybe people too. So, by inspection, if we find something wrong, we design, fix, and so on. So, to improve quality or maintain quality, we need appraisal and prevention cost. Good. Okay, next. By testing, inspection, we find something defect and then cause of defect and change with design and so on. Try to solve the problem, but still there is chance make defect. If we find defect internally, that is internal failure cost. Cost for defect incurred within the system, then scrap, rework, and repair and something that also time and cost. This marker from Vienna, 1 year, 3 months ago. Does they work good? Typeword. Okay. Inspection, test, find the defect, cause, change, and so on. But still, we can find the defect internally, that is internal failure. So we think all problems solved, but still there is chance defect which customer. Then what happened? That is external failure cost for defect that has to the system. Warranty replacement, loss of customers, or goodwill, handling, complaint, and repairing. After that, the reputation lower, and then lose customer, that is opportunity cost, and so on. So cost of quality, appraisal, prevention, internal, external failure cost. They are cost of quality. Have you heard of QM, Total Quality Management? Many years ago, total quality, TQM was a buzzword and hot issue. But now, no, because everybody do. The collective efforts of all managers and employees, company-wide, try to make better. Total quality management using whatever tool, whatever concept and technology, entire organization, using TQM, make it better, cheaper, faster, and increase sales. Nothing special. So, make it better, cheaper, faster, using whatever tool, concept, technology, and entire company-wide efforts and next one, Six Sigma. Have you heard of Six Sigma? Like a black belt, something training. This Six Sigma from this statistics. What is this? What is this? Standard deviation, sigma. Six sigma. Plus minus 1 sigma, about 68%. Plus minus 2 sigma, 98%, like this. Plus minus 3 sigma, 99.72%. That means if a company use 3 sigma quality specification or quality policies, something like that. If a company use 3 sigma quality philosophy, if produce 100, 0.27 up to 0.27 defect allowed. 1,000 2.7. Produce 1,000 items and then find defect less than 2.7. Then the process is working. 10,000, 27, 100,000, 270. 1,000,000, 2,700 defect allowed. Too many. So use Six Sigma quality policy or philosophy. Then a process that is in Six Sigma control limit will produce no more than 2 defects out of every million. So with the Six Sigma quality control policy, up to 2 defect out of 1 billion allowed. Go back. So, this moment, a philosophy and set of methods companies use to eliminate defects in their product and processes. 6, to reduce variation in the process that lead to product defect. So, try to make better. That means no defect. By Six Sigma control limit, 2 out of billion. That means perfect, right? So how? Using whatever tool, concept, technology, and training, and many concepts, tools, and in operations management, not to make defect. That is Six Sigma. Hyundai use PPM. It's similar to PPM concept. problem per million, ppm, problem per million. So then they try to make better products. Suppliers inspect or test supplier every year. Then how many defects the supplier make, and then something category 1, 2, 3. So you are your company is category 1, less the defect make, something like that. So try not to make defect using the ppm concept, similar to this. That ppm from this based on this Six Sigma, 2 out of billion, too many, right? Billion is too many. So usually companies use 1 out of million. 1 out of million. So 2 out of billion or 1 out of million is the same concept with Six Sigma. So 2 out of billion or 1 out of million is the same concept. So many companies use 1 out of million, like Hyundai. ppm is problem per million. That also kind of 1 out of billion. So 2 out of billion or 1 out of million is the same. Okay? Single system. Fail-safe design philosophy, named after the co-developer of Toyota just-in-time system. We will talk about just-in-time later. Serial single